Welcome back to our series on Introductory Statistics. I'm Mark Ledbetter. This is lecture video 27, part B, and we are in section 8.1, and this is the second part of that. So earlier in this section, we talked about the common point estimates, and these are statistics that we calculate from the data. And so these are single values, and that's why they're called point estimates. So X bar estimates the population parameter mu, S squared estimates sigma squared, S, the sample standard deviation, estimates the population standard deviation sigma, and P hat estimates the population proportion, P. And all of these are unbiased except for the sample standard deviation. We talked about a confidence interval, which we have abbreviated as CI. It's a range of values. And we said that the length of the interval is determined by the confidence level and the sample size. The confidence level is the probability that the confidence interval contains the actual population parameter that we're estimating. We said that each time that we take a sample, we're going to get a different estimate of our statistic, our point estimate. So if it's X bar, every time we take a new sample, we get a new value of X bar. And since our confidence interval is X bar minus E, then we get a different confidence interval. And so the confidence level C tells us what proportion of the time our interval, our CI, confidence interval, will actually contain the population parameter. So if C is equal to 95%, then 95% of the confidence intervals that we calculate using that sample size will actually contain mu in this case, since we're estimating mu. Okay? But that would mean that 5% do not contain mu. So anytime we calculate a confidence interval, we don't actually know if it contains the true mean of the population. Okay. We have some requirements in order to use the formulas and the methods from this section. First, we have to have a simple random sample, and the sample size is always n. Secondly, we need to know the value of sigma because our value of E has sigma in it. So we cannot use this formula unless we know the value of sigma. We also said that we have to know something about the distribution of the random variable x. If it's normally distributed, then we can have a sample size of any size, any value. However, if x is not normal, or if we don't know the distribution of x, then we need at least 30 for our sample size. We said that z sub c is a critical value, and we look it up in our z-table. And then finally, we gave the formula for the confidence interval, which is X bar minus E. This is our lower value of the confidence interval, and our upper value of the confidence interval is X bar plus E. So let's do an example. We have a runner that jogs 2 miles every day, and she has measured her standard deviation as 1.8 minutes for the entire time that she's been running. Okay? And she takes a simple random sample of n equals 90 times from the past year. And the average of this sample is 15.6 minutes. We're going to let mu be the mean jogging time for the entire distribution of her running times for these 2 miles that she does every day. We want to find a 95% confidence interval for mu. So we need to check our requirements. So the first is that we have a simple random sample. check. She says it right here. Simple random sample. Then, since n is equal to 90, and that's greater than or equal to 30, we are good to use the formulas. Okay? And then finally, sigma is equal to 1.80 minutes. So we know that. So we've met the requirements. Now, how do we find C? Well, go and look for the confidence interval, the word's confidence interval, and usually the percentage that's the confidence level is right in front of those words. And in this case, it's 95%. So we're looking for confidence or confident. And the number, the percentage, or the decimal number that's associated with one of these is the value. So this is 95%, which is equal to 0.95. And so our critical value is going to be z of 0.95. So we go to the z table and we find 0.95 or 95%, and we see that the critical value is 1.96. And then n is given to us in the problem, which is 90. Now we can calculate our margin of error, our E value. And so z sub c is 1.96. Sigma is given to us as 1.80, and the square root of 90. And when we calculate this, 1.96 times 1.8 divided by the square root of 90 gives me 0.371883, etc. Since sigma is rounded to 2 decimal places and x bar is rounded to 2 decimal places, I'm going to round this to 2 decimal places. So we're going to use 0.37. And so our confidence interval, make sure you write down your formulas and then plug in the values on anything that you turn into me. Okay? So for the confidence interval, we write down the formula x bar minus E, and that's less than mu, and then x bar plus E is greater than mu. And so now we plug in the values. X bar is 15.60 minus E, which is 0.37, and then x bar 15.60 plus 0.37. So 15.6 minus 0.37 is 15.23 minutes. And the upper number is going to be 15.97 minutes. So our confidence interval is here. Now it's time for us to do the most important part, which is interpret it. So here is the formula or the sentence that you need to write on your formula sheet. And so if you say it this way, you will not get it wrong. If you change up anything, you may get it wrong, okay? So we have to be very precise in how we say this, or else we're going to say something that's not true. So we are 95% confident, so we put C in the first blank, that the interval, and now we write this in interval notation, so 15.23, comma 15.97, contains the population mean for this runner's time for 2 miles each day, calculated using a simple random sample of size 90. So this is n that goes here. And so we have successfully interpreted the confidence interval. So we've calculated the confidence interval, which is here, and we've interpreted it here, which is, again, the most important part. Up until we interpret, we've just been doing math. Okay? So in the next video, we'll determine, we'll talk about how we determine the correct sample size for a study. Please update your formula sheet as you need. Remember that you can have definitions, you can have the names of symbols or any notes that you want because it's your formula sheet. If you have questions, please come to office hours or you can email me. I'm always happy to help you with the course content. Please take care of yourself, stay safe, because we hope to see you here next time.